Alrighty, this part of our Chapter 1, we're going to talk about the OSI model. Now, OSI model, you might as well realize right off the bat this is kind of like multiplication or fractions when you're in elementary school. You're not going to get away from it. You're not going to be able to get around it. It's something you're going to have to tackle or at least understand to some level. So let's dig in and do the best we can. Why we're going to discuss this is a way to dissect and learn about how data moves across the network. It's also a way to start diagnosing or talking about pieces of a network, and eventually a way that we can talk about ways to troubleshoot a network. In CNT125, I actually have my guys work their way through a troubleshooting lab, doing layer 1, layer 2, layer 3, layer 4, trying to get them to realize there's different tools you use depending on what you're trying to diagnose. Alright, one thing we want to keep in our brain to kind of help with this, remember mailing a letter. If you're going to mail a letter, it is a process. You know, you write the letter, stuck it in an envelope, you write your sending address on, you write the return address on, you put a stamp on, you put it in the mailbox. And as long as they follow that process, the postal carrier can pick it up. They start reading that letter and making decisions on getting it to the destination, and then it gets to the destination and that person kind of reverses the process to open up the letter and extract your message. Well, this is kind of how data moves through a network. As long as it follows a specific process, data will move through the network, get to the destination, and be readable. That's kind of the end goal of where we're going with this whole OSI model thing. That's kind of the end goal. So if I look here, you know, the whole, if I do my sending of the letter correctly, it'll move through the postal system and it gets reversed, and the receiver will be able to extract that letter and read the information of inviting them to a party or whatever it happens to be, whatever that letter happens to be. So that's kind of what we're after with data flow. All right, they like to show you pictures like this, and that's what they're getting at. If I'm going to send a chunk of data from this computer to this one, it has to go down through these layers, do certain things, move across the network, and then up and reverse the process on the other side to get to this computer and display that email or whatever it happens to be. So that's what we're trying to get at. All right, so let's dig in. The OSI model, Open System Interconnection Model, was developed in the 80s by ISO, an international standardization organization, as a way to, again, if we think back to the earlier history I said, when we moved to personal computers, all these computer companies started building their own network to connect their own computers. And what they were really doing was building their own network using their own NICs, their own cabling to connect their own computers, and they were doing it using their own protocols. So you had a series of Apple computers connecting with Apple NICs and Apple cables and Apple switches, if you will, using Apple protocols. The same thing for IBM, the same thing for Xerox, and the same thing for DEC, and the same thing for on and on and on. So along comes ISO saying, look, we need a way to standardize this. So they come up with this OSI model as a way to try to start standardizing network communications and hopefully start getting all of our network standard that I can plug a computer in anywhere and it works. Well, we know the end result. They started this work in the 80s, and if we take our laptop to any campus, any Harrisburg campus, or most coffee shops or whatever, our computer can connect up and get to the internet. So we know their end result worked. We just don't know what happened along the way. All right, so they developed two things. The ISO developed two things. They developed a layered model for network architecture, that's the OSI model, and they also developed a set of protocols. Well, I'm going to ruin the surprise. The model is still around and we still use it and talk about it, but the protocols are not, so to speak. The protocols were developed, but they were not really adopted. What ended up getting adopted was the default TCP/IP, or I should say, it is now kind of the default TCP/IP protocol stack, or protocols are kind of the default that everybody uses. So the model was developed to try to kind of standardize everything, but we ended up not using the OSI protocols. We ended up using TCP/IP. but we still have the model around and we still use it as a reference. So they call it the OSI reference model to reference data communications and how things work on a network. And actually, here's the X200 series of recommendations. These links point you to the ISO documents on the OSI model. There's some evening reading if you're having trouble sleeping. All right, so if we keep moving, the purpose was to create this set of standards that if I develop a NIC, if I develop a brand new network card, I should be able to snap it in any computer and it works on the network, Ethernet network, that kind of thing. Yes. Well, today we know that has occurred. Over many years that has occurred, and it does happen. So this work was valuable. Well, since we're not using the OSI protocols, you could say, well, we don't really need to learn this. But yeah, we do. The OSI model is a way to study this very complex process of sending data through a network and breaking it down into little pieces. Just like if you're a mechanic, I don't study the whole automobile per se. I might study how the brakes work in a car. Then I might study how the fuel injection system works in a car. Then I might I'm studying pieces. Well, the OSI model is going to allow us to do that. I can study pieces or learn pieces of a network. It's also a common language for IT professionals. You're going to read articles and things we're referring to when dealing with Layer 4 security, when dealing with Layer 3 protocols, when dealing with Layer 7 applications. You're going to see that. You're going to read that. So it's one of those, you kind of have to know the lingo to know what the heck they're talking about. And it is going to eventually help with troubleshooting. It sounds bizarre, but down the road, I'm going to try to get you thinking troubleshooting Layer 1 to 7. You work your way from the easier stuff to the harder stuff. So there is some application to this down the road. All right, here it is. Here's the OSI model, 7 layers, 7 to 1. You'll notice that they're arranged 7 at the top, 1 on the bottom. Think of this just like floors of a building. The 7th floor is up high. The 1st floor is down on the bottom, or ground level, if you will. Just like floors of a building. The other way to think of that, too, is because of that, if I rip the 1st floor out of a building, all the floors above it are going to fall apart. Just like a network. If I rip the Layer 1 components out of a network, nothing else is going to work. Well, just to give you a quick idea, Layer 1 is your patch cables and cabling. If you rip those out of a network, it's not going to work. Well, Mr. Brown, what about wireless? Well, that wireless access point has to connect into a switch somewhere, or that switch into a router somewhere. Yes. If I pull my cabling out of a network, it's going to fall apart. Exactly. That's why they purposely have 7 on top and 1 on the bottom. Okay. And here's another example of this is actually the one the book uses, where they have 7 on the left, or 7 up here and 1 on the bottom, showing the same thing, and they have a little breakout showing you some of the things that are occurring at each of the layers. All right. So there's 7 to 1: application, presentation, session, transport, network, data link, physical. We need a way to try to remember these. Well, here's one mnemonic that'll help you get them in order. This is one of the ones the book uses. All people seem to need data processing, 7 to 1. Okay. I always preferred this one, where I go literally 1 to 7. Please do not throw sausage pizza away. Sausage pizza. If I go, please do not throw sausage pizza away, I'm going 1 to 7, and I'm going physical, data link, network, transport, session, presentation, application. It works. For as silly as it sounds, it works. So maybe you find one of those mnemonics to get these layer names in order, and do get them down and get them in order. You will need them. Okay? You will need to have them and have them in order. All right, so here's our layers. Let's get through the first couple layers, and we'll take a break, and then on the next podcast, we'll do the remaining layers. Their purpose is starting at layer 7, because again, we're going back to this example of if I'm going to send a chunk of data, I'm going to send it from my computer down through the layers, onto the network, across the network, off the network, and up through the layers to the receiving computer. So their purpose is starting on 7 for that reason. We're kind of doing the whole sending a chunk of data, if you will. So layer 7. Layer 7, we're dealing with applications. We're dealing with applications network related, if you will, not Microsoft Word. Okay. This is the interface between the application on 2 separate computers. So again, I use the example of, Microsoft Word. Do I need an application to use Microsoft Word? Or do I need a network to run Microsoft Word? No, I don't. I don't need a network to run Microsoft Word. If I have something like my web browser, Firefox, Google Chrome, whatever it is it useful without a network? No, it's really not useful without a network. So I kind of need a network to use my browser. Yes, we're talking about that kind of thing. And really the browser, as we talked about earlier in this chapter, the browser is using HTTP. Those are the applications we're talking about. That's why up here you see World Wide Web, HTTP, HTTPS, email, SMTP, POP, IMAP. That's what we're talking about. Okay? FTP, FTP, FTPS. Those are the applications we're talking about, these network applications, if you will. That's what we're trying to talk about. So this layer interacts with the software applications that implement a communicating component like my software application like Firefox, Internet Explorer, Mozilla, whatever it happens to be. Those are interacting with HTTP and HTTPS. Things like my FileZilla is interacting with FTP. Things like my Outlook or Thunderbird or whatever is interfacing with SMTP and POP3, and so forth. These are the communicating components we're talking about. From my browser over to the web server. From my FTP client to the web server that's hosting that file or saving that file for me. That's what we're talking about, the application layer. So that's why they had those up here in the application layer. That's what we're talking about. Layer 6, presentation layer, we're now talking about responsible for formatting, compressing, or encrypting the data in such a way that the receiver can read it. Example, an email message can be encrypted at the presentation layer by the email client or by the operating system, and as long as I encrypt it in, let's just say, the Doug Brown encryption method, when I send it across the network, when the receiver gets it, as long as the receiver uses the Doug Brown de-encryption method, they'll be able to read that email. Okay? So the presentation layer is responsible for getting things formatted in such a way that the receiver is able to either reverse that encryption process or be able to read it. Well, let me give you an example of how we know this occurs all the time. If I use my Thunderbird email application to send you an email, and you're using Outlook, can we still communicate? Well, that's one of those questions you often go, well, I never thought about that, and I guess so. Well, yeah, because when I send my email, when I hit send, it's typically leaving my computer as a TXT file or an HTML file. And your email application, you're in Outlook or whatever it happens to be, receives that. Can it read a TXT or HTML? Well, yeah, because just about any computing device on the planet can read a TXT or HTML. Yeah. So really, if you dig down deeper, let's say my MacBook running Thunderbird sends you an email, and you open on your Windows 10 computer using Outlook, you can still read that email. You know it, you've done it, you've seen it, you've responded to that, and you send an email back. You never cared what your operating system was or the email client or anything, because we're using a common file format when we're sending or receiving our emails. That's the job of the presentation layer. Get things in some kind of recognizable common form that the other end will be able to open and read it. And that also includes things like encryption or compression. If I'm going to encrypt or compress, it needs to be in some format that the other end can read it or open it. And I threw these examples in just to get you thinking: JPEGs, MP3s, MP4s, that sort of thing. Encryptions like triple DES. If I encrypt this end in triple DES, you should be able to decrypt on that end. As long as you have the key, you should be able to decrypt on that end, because that is a known algorithm, if you will. That's all the job of layer 6, or the presentation layer. All right, session layer. This is a little tougher to wrap your head around, but this is the one. If I'm going to send a message, I have to get things synced up and maintain that communication session, so that if anything gets disconnected or whatever, we can reconnect and finish our communication session. So this is how data applications are synced and recovered to make sure everything gets there. That's the job of our session layer. So this is the one that's kind of controlling this dialogue connection between the computers, establishing, managing, and terminating the connections between me and the other computer. Sometimes you go to open something in your browser and says your session has been terminated. Yeah, it's taken you've been away too long. It could not keep that session open. You have to reconnect. That's what's going on with the session layer. All right, we'll come back in the next one and talk about layer 4.